Hello, and thanks for using TickBoom, a free service that helps high school students with their math problems. In this video, I want to revisit part 2 of this question, which told us to form a quadratic equation with roots cos 2 pi on 5 and cos 4 pi on 5. So last night I uploaded a video where I tackled this, and the approach I used kind of followed on from the working I had done for part 1. And I kind of fell into that classic trap of thinking that the techniques I had to use needed to be complex because it followed on from a question part 1 that itself was quite complex. But having reflected on this overnight, I was actually sitting in my orientation for my Masters of Teaching today, and a light bulb went off where I realized actually this is just a quadratic. It's actually really simple how you can come up with this quadratic equation. So what I want to do in this video is just work through that much simpler approach that you could have taken. So if you haven't seen my first video, I'd suggest you go have a look just so that you can see what instinctively came to me last night. I mean, it's a little embarrassing that, this much simpler approach isn't what, came to me first, that actually, my instinct was to go down the more complicated path. Ideally that wouldn't have been the case, but anyway, that's just how it went. But once you've had a chance to look at that approach, come back and check out this video, because you'll see that this alternative approach is just much cleaner and much simpler. So basically the approach I want to use here is, it basically starts from the fact that any quadratic we can write as x minus alpha, x minus beta equals 0. That equation will be a quadratic with roots of alpha and beta. So if we kind of expand this, we'll get x squared minus beta x minus alpha x plus alpha beta equals 0. And then I can just tidy this up and we'll have x squared minus alpha plus beta x plus alpha beta equals 0. And this is a format of a quadratic that you probably would have learned many years before, taking on extension 2, which is where this whole question comes from. This format helps us learn that you can write a quadratic such that the coefficient of x will be minus the sum of the roots, and the constant will be the product of the roots. And this is a kind of format that you would have used probably many times before. Now what we have to do is say, well, if we want cos 2 pi on 5 and cos 4 pi on 5 to be our roots, then we just let alpha equal cos 2 pi on 5 and beta equal cos 4 pi on 5. Insert those values into this form of the quadratic and we'll have our answer. So you can see this is much simpler than what I initially went with. What I got to yesterday was technically correct. We even checked it to make sure that these two values got us to 0. So it's not like it was necessarily wrong. It's just unfortunate that it was much more complicated than it had to be. I think often with math you want to kind of take the simplest approach possible. And so yeah, that's why I wanted to kind of do this Postscript video and just make it very clear that there is a much simpler way. So if I now insert these values, we'll get x squared minus cos 2 pi on 5 plus cos 4 pi on 5 x plus cos 2 pi on 5 times cos 4 pi on 5. That's all equal to 0. And at this point, so we'll get x squared minus, and at this point I'll just plug this into my calculator. So we'll get cos 2 times 180 divided by 5 plus cos 4 times 180 divided by 5. So that's going to be minus negative a half x plus, and now we'll do cos 2 times 180 divided by 5 times cos 4 times 180 divided by 5. So that's going to be minus 1 on 4 equals 0. So this will clean up to x squared plus a half x minus 1 on 4 equals 0. Now I think where I got to last night, I actually effectively multiplied everything by 2. So I got 2x squared plus x minus a half equals 0. And that's kind of where I stopped using the approach I took last night. Here, if you wanted to clean this up a bit more, you could even you could have effectively multiplied by 4 here, or now at this point multiply by 2 again, and you get 4x squared plus 2x minus 1 is equal to 0. And they're both kind of valid quadratics that have these two values as their roots. So yeah, hopefully you can agree that that is a much simpler approach compared with the alternatives that I went with last night. So hopefully you found this approach easier to follow. I think if you came across a question like this in an exam, hopefully you'd instinctively go to this format as a way of thinking about that question. So if you found this explanation helpful, please be sure to give it a like. And if you're someone who wants to keep their finger on the pulse with the kinds of questions that other students are struggling with, be sure to subscribe to my channel so that you can stay in the loop. Alright, tick boom.